Today we're going to look at how to graph a quadratic equation from standard form. All right, the standard form of an equation is f of x or y equals ax squared plus bx plus c. We're going to use this first equation, first a set of rules. And believe it or not, even though it looks wordy, it's the same rules we use for vertex form of the equation, except that we have to identify the vertex a little bit differently. As you can see in standard equation, there are no parentheses, so there's no grouping of a quantity squared to pull out the h and the k value to give us the vertex. So we have to do a little formula. And our formula is, to get the vertex, is x is going to be equal to negative b over 2a. And that x is the vertex value of the x value of the vertex. Before we start, we always want to identify a, b, and c in this quadratic equation. So here's our first quadratic. It's f of x equals x squared minus 8x plus 13. And we want to identify the a, the b, and the c value. So if I took a template and I just wrote this over it or under it, we would see that in the a position, there's a 1. Okay, as always, when you don't see the number, it's a 1. So we know a equals 1. In the b position, b is always added to the ax squared term. So whatever you see here is the b. So it's negative 8. And c is the standalone number that's added after that or subtracted, and whatever you see there will be c, and that's a positive 13. Okay, so what we want to do now is we want to get the x value for the vertex. In order to get the x vertex value, sometimes I'll just label it like that, I'm going to take the opposite of the b value divided by 2 times the a value. So x for the vertex is going to be the opposite of a negative 8. The negative 8 has nothing to do with the opposite value in front of that b. So it's opposite of negative 8. Always put your b value in parentheses. All over 2, and the a value is 1, so we put that in parentheses as well. Now we're going to calculate. The opposite of a negative 8 is a positive 8. 2 times 1 is 2. And now we're going to divide and reduce, and that's going to give us 4. So the vertex x value is 4. All right, so we're getting ready. All right, so our vertex is 4 comma something. Now to find the something, the y value, we have to take our 4 and we plug it in or substitute that x value that we found for the vertex into the y equals or the f of x equals equation. All right, so our equation is f of x equals x squared minus 8x plus 13. So what we're going to do is we're going to substitute in, and we're going to say, all right, f of 4, we're going to put that 4 in for x, is equal to 4 squared. And remember, whenever you substitute a number, you put it in parentheses. Minus 8 times 4 plus 13. I'll move this out of the way for a minute. So now we're looking for y. So f of 4 really means y. 4 squared is 16. 8 times 4 is 32, so minus 32, and then plus 13. Now remember, by order of operations, you have to order in left to right order. You have to add or subtract in left to right order. So you got 16 minus 32, so it's negative 16, and you're still adding 13. So y is equal to negative 16 plus 13 is going to give us negative 3. So now we can complete our vertex. So it's going to be 4, negative 3. All right, now the other thing we want to look at is the a value. Well, our a value is 1. So when it's 1, we know it's going up because it's positive. So direction is still identified the same way. A still tells us the direction up and down. Okay, if it's positive or negative, and the shape, same, narrow or wide. So all of this is identical to what we did in the vertex form. Okay, so when we're looking here, our a value is 1, so it tells us it's going up because it's positive. The shape is going to be the same as the parent. So right and left 1, square it, up 1. Right and left 2, square it, up 4, etc. And we can still get our line of symmetry. So we'll abbreviate that L of S. All of this without graphing is reachable. And it's always x equals, and it's the x value of our vertex, so that hasn't changed. And because it's going up, we're going to have a minimum point, And that value of the minimum point is going to be the y value of our vertex, so -3. So all that information is still gotten from A, and then we just have a little thing to do here to get our vertex for our x and our y, and then we graph just like we always did. Okay? So I'll move our rules for a minute, and let's start graphing. All right, so graphing. Our vertex is 4, -3. So this is our x-axis, this is our y. So we're going to go 1, 2, 3, 4, 1, 2, 3. Our shape is the same as the parent, so, and it's going up. So we're going to move right and left 1, square it, go up 1. We're going to go right, left 2, square it, and go up 4. 2, 3, 4. Use symmetry on each side. Let's go for 3 just because this is a pretty large coordinate plane. 1, 2, 3, left or right, we square and go up 9. So that's 4, 5, 6, 7, 8, 9. And use symmetry. And then draw yourself a nice parabola. And just try to nail those points there. All right, so that's our parabola of f of x equals x squared minus 8x plus 13. We've done it. All right, let's take a next problem we have, okay? All right, so for our next problem, we want to identify, always want to identify our a, b, and c. We look and we see this is ax squared plus bx plus c, okay? So f of x equals ax squared plus bx plus c. So a is -2, b is +8, c is -3. Now, the reason I'm having you identify A, B, and C, although we don't use C for any of this, is because we're going to need it later. So we might as well get used to identifying A, B, and C, not leaving C out. All right, so we're going to now get our x value for our vertex. X value is the opposite of B all over 2a. So x is the opposite of 8 all over 2 times a -2, because our a value is -2. That's going to give us -8 over -4, which is reducing to 2. So now if we want to get our y value, we're plugging in that 2 for x. So f of 2, which is also y, is equal to -2 times this 2 that we're going to plug in and square it, plus 8 times this 2 that we found for x vertex and put it in, and then -3. All right, now, I mean, at this point, you can take a calculator and type it in exactly as you have it, including the parentheses, which is why it's important to do the parentheses. But if not, you can say y equals, this is going to be -2 times 4. This is going to be multiplied 16 minus 3. This is going to be -8 plus 16 minus 3. This is going to come out to be +8 minus 3, so it's going to be 5. So our vertex, we'll use this space over here. Our vertex is going to be 2, 5. We know our direction is down because our a value is negative. We know our shape is going to be narrow because our a value is a 2, okay? So it's narrow, ignoring the sign. We just look at the number part, okay? And now we can do our line of symmetry here if we want right away. X equals the x value from the vertex, so x equals 2. And because it's going downward, we have a maximum point. And the value of that maximum point is our y from our vertex, which is 5. So we've answered all these questions, and now we can graph. So this is our x, this is our y. Our vertex is 2, 5, so 2, 1, 2, 3, 4, 5. We're going down, and it's narrow shape because it's twice as much as the parent. So the parent moves left or right 1, squares goes down 1, but this is going to go twice that amount, so go down 2. Use symmetry on each side. Parent moves left or right 2, squares and goes down 4, but this says go twice that amount, so we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Use symmetry on this side. Okay. And that's a good parabola. If you wanted to do more, you could do more. You can go out 3, square it, and go down 9, and then double that to 18. It'll bring you down here somewhere. Okay? So this is our parabola f of x equals negative 2x squared plus 8x minus 3. And all the information that we always pull off of it. All right, one more. Okay, we're going to graph at y equals 1/2 x squared minus x minus 5. So our a value is half. Our b value is negative 1. Okay. And our c value is negative 5. Okay. Our vertex is, for the x value, is x equals the opposite of b over 2 times a. So x equals the opposite of a negative 1 over 2 times 1/2. Well, the opposite of a negative 1 is 1. Half of 2 is 1. So 1 over 1 is 1. So that's our x value for our vertex. Now our y value is equal to 1/2. Plug in that x, square it, minus 1 times 1. Plug in that 1 again, and then minus 5. 1 squared is 1. 1 times 1 is 1, and minus 5. Half times 1 is half. Minus 1, minus 5. Half of minus 1, you have to go in order. Y equals to a negative 1/2. And we're subtracting 5 more. So y is going to give us 5.5. So our vertex is going to be 1, comma, so that's a negative 5.5. We need our negative sign on there. Negative 5.5. We're looking at this and we know it goes up because a is positive, so our direction is up. We see that it's growing at half the rate as the parent, so we know the shape is going to be wide. And we can do our line of symmetry if we want here. X equals the x value of the vertex, so x equals 1. Because it's going up, we're going to have a minimum point, and the value is the y value of our vertex, so negative 5.5. So all that information gotten, let's graph it. We're going to go 1 to the right and down 1, 2, 3, 4, 5.5. So it's kind of midway. When we move 1 away, we're still in the half box going vertically, but not horizontally, right? So we go 1 away, we square it and go 1, but the parent, according to the parent, but this one is going half that amount. So we're going to go down a half. Another way you can do this, though, and make it easy, because your denominator is 2. Move 2 away. Square 2 and go, your parent says go down 4. And then because we have a 2 in the denominator, divide your 4 by 2. Divide it in half and go down 2. 1. So 1, 2. And remember, you're still in the halfway box. So again, watch this. Okay, we move 2 left or right. Square it. Gives us a 4. To go down by the parent. That's what the parent says. Parent rule. But the half of what the parent says is half of 4, which gives us 2 down. And this is the equation we have. All right, use symmetry on the other side. So move 2 away and go 1, 2 down. All right, now I would move 4 away now this time. So if I move 4, left or right, so 1, 2, 3, 4, right? That means I would square it and go down 16, right? That's the parent rule. But because I'm dividing by 2, half that amount, I'm actually going to go down 8. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And use symmetry on each side. Remember, you're moving 2 away from where you were, so 1 over, 2 over. 2, and there you go. And you got a nice parabola. That's a nice way to do it. And if you use IXL, that's how you would do it on IXL, as you saw from the vertex form. And that's how you graph quadratic equations that are in standard form. A real quick review: identify A, B, and C. Get your x vertex by doing negative b all over 2a. Take that value, plug it into your f of x or y equals, and get your y value. You got your vertex. A still tells you up or down, tells you about the shape, and you can still identify your line of symmetry and min and max value from your x and y values of your vertex.